Hey, it's James from Finny Electrical. In today's video, we're doing a fuse board changeover. So I had a nice little call out to this one the other week. So basically the fuse board was smoking and it was nearly setting on fire. You know what I mean? So I'll show you that, flipping it. So here it is. There's a little fuse box. So what happened is they've basically wired two circuits into here and it was just rammed in the top and this was overloading. So this is rated to like 30 amps by the 30 amp fuse and there must have been at least 50 amps going through this. So this is the fuse carrier. Oh dear, it's a bit knackered that, isn't it? So they nearly had a fire. How bad's that? Up in next, yeah, there was smoke billowing out over here. It were awful. So yeah, we had to give that a quick fix. Obviously said to customer, right, don't touch that. Get a little cover on there, and then we're back today just to do the fuse board changeover. So it should look a lot nicer. So what we're going to do is get a fuse board in here. So there'll be a little fuse box just to sit in here like that, and that'll serve the old circuit. So here we go. Yeah, so I hope you've liked the tour series that we've been doing. So obviously we had the bag tour, the van tour. So now we're back onto the shout outs. So shout outs for this week. So we've got a shout out for this guy who I don't have to say because it's in Arabic. So I think it translates to electrical services. But there we go. This guy, my camera won't even focus. So yeah, that's the best shout out I've done so far. So yeah, if you want a shout out, all you need to do is just comment in the live chat on a Sunday at 8 o'clock. You need to comment on the video and then I'll basically just scroll past the comments of previous weeks and pick someone at random. So that's how we do it. Alright then, so fuse board time. I've got all my gear out, got my veto pack, got my drill, all the breakers, the board, and then everything I need to do to fix it and extend cables within the board. So then, this is what we're fitting. We're fitting a dancing. So these are brilliant. So really good quality. Yeah, everything's just really solidly made. Sometimes with boards you get the breakers in, you tighten it up and they all go and they all just spin to the side, but these, when you tighten them up, they're all just set nice and solid in there. So I really like using this fuse box. Right then, so we'll get this opened up and we'll populate it with those breakers. Oh, we've got a new tripod for the GoPro as well. So I don't know why I keep it in my climbing shoes, but there we go. I'll do a bit of filming when we go climbing. It's right, little beast. It's a little 3-tier thing. So there we go, new and improved filming, I'll do. So here we go, that's the lid unscrewed. So with these dancing boards, you get a little buzz bar cover. No, buzz bar cover, you get your bus bar, and you get some grommet strip, which is no good, so always chuck that away, you know, that's dead. Right, it's not very good, it's just really, I don't know. Let's get it out, I'll show you. I never show you this strip. I'll just throw it away and Morgan plays a dead scene. It's just really like not flexible at all. So you put it in and it just, yeah, it's no good. So I've got my own grommet strip which actually works. So get rid of that. But that's the only bad thing about this board is the grommet strip, which isn't too bad. So what we're going to do is populate it now. So we're going to slide these RCDs over like so. And then the way I like to populate it from big to small, so I like 40, 32, 32, 26, so that's going to go on one side, and I like to do 5 and 5, so you put 5 circuits one side, 5 the other, like that. There we go, next one, 32, 32, 20, 26, bang that in, there we go. It's quite satisfying when it clicks in as well, I do like that. Right then, so that's it populated. So what we're going to do now is take 2 little grub screws out this side, this pops out, you undo those 3 for the 3 neutrals, and then we've got the shell ready to mount. So here we go. Nice little tip. So if you saw from my van tour video, there was a magnet on top of my roof and I magnetised on my screwdrivers and that. So as you're taking it out, look at that. Well, it's magnetised so you don't lose it. Amount of times if it's not magnetised, you start unscrewing it and you lose it. So you can either put these to safe to one side or screw them back in. So to be fair, it changes when I do it. So sometimes I screw them back in nice and tight. Sometimes I just leave it. a safe place. We'll screw him back in today. There we go. Right then, let's offer this this guy up and see where we're going to fit him. There we go. Right then, just going to fit in here somewhere, and if you look here, there's like it steps off a bit because this piece of wood. So what we might have to do is just get it mounted over this, well, I fix it on here and then stack it off with some penny washers at these three corners. So if not, it's not going to go in, is it? So there we go. So I think best bet, it's going to have to sit there, isn't it? That's going to be the best position for it. So we'll go with that then. And this door should shut, but we need to check that. So all I'll do is just measure the depth here, add it to this this little sticky out bit, and see if it lands past the door or not. So best check that first rather than get it all fitted and then they have to move the door. So but yeah, it's gonna have to go in somehow. So it might be that they might have to rejig this door later and just bring it forward a bit, but we'll see how it goes there. Right, let's whip this cover off then. So turn the power off, undo these little fuses. See, it's all just crumbling apart in here. It's been awful. So it's not very well fixed. So it's just 2 screws in that I left over the years. I've lost me the screwdriver wherever that's gone. We'll get this top one out. There we go. Take the cover off. So these are the old Wilex boards. It used to be like Wilex and Bill back in the day. Get that on the floor. There we go. So I like this little tripod. You can get it in every little place. Right then. So these are your cables coming in. These are your line cables here. So what we'll do is tally these up to where they're going to go in the new fuse box. So example, we'll tally this one, even though it's got a little one on it already. We'll tally that up 1, and that'll be like shower or whatever on the first position of the fuse board. And say like the lighting, we'll tally that up number 5 because that's the lighting one. So that's the 6 amp. So we can do 5 tallies on there. And when we bring that cable into the new fuse board, we know that the line cable will go into 5 on the new fuse box, so and so on. So we'll get all this tallied up now. We'll get it all removed, and then we'll map through some magic to stop these becoming live, but we won't show you that. There we go, that's what's left of the fuse box. So there are all your circuits, surprisingly enough. So they power up all your house basically. So they're all tallied up, as you can see. So all we need to do is obviously get these into the new fuse box, and then obviously they're quite short, so we'll have to extend these to the new positions. So there might be a bit of slack on them, so we might pull them, see if we can get them down. But let's have a look. Let's offer up as fuse box. So there might even come rear entry on the top left, so that might be quite handy. And then all the connections can kind of hide up the top. The tails aren't going to be long enough, so these are called the tails. These big chunky monkey cables. So these are 16mm tails, so they're not going to be long enough to go to the main switch, which is the big red one on the internals. So what we're going to have to do is put a thing called a Henley connector block, or what Hayden called it this morning, a Henry connector block. I don't know, it's just a brand on it, but so we'll have to fit this in somewhere. I haven't decided yet. So I could even put it next to the fuse board, or I don't know, I could bang it here and then come out the bottom of that with some new tails to the fuse board. I haven't decided yet. So best bet is to get the board mounted, and then we can kind of position this where it needs to go afterwards. So here we go. Right, so what we'll do is just knock this out and we'll get this mounted next. There we go, beautifully grommeted up, and then we've just got some white tape around that just to seal it in, because it's a nightmare when that pops out and you got cables in there. It's really hard to get back in. We've also got his little tails grommet there, so you can see there's 2 holes there. Looks like a little shock face. There we go. So we've got 2 16mm holes there for the 2 16mm brown and blue. That's your 11 neutral, and you got your 10mm hole there for your earth. And that's about it. So we'll get this up, and there we go. We'll start extending these, get the neutrals and earths in, and we'll see how far we get. go, that's all the neutrals and earths in now, so that's looking really nice. So they're just all moulded in nicely. So we had to extend quite a lot of them. So we just use these little 2-hole push connectors and then just tucked them way up there. So they all just nicely go into there and extend to the relevant circuits. So like I said, when we tallied up, obviously tally 5 for this one, for position 5 on neutral, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we tallied up 5, we banged 5 for the neutral in there, for the blue one, 5 for the earth, and obviously you got that cable there with 5 on, which is going to go in the 5th position for the MCBs. So we'll get the MCBs in now. So we'll just take these 2 screws out, get that fitted. You got the neutral from the incoming going to this one, neutral RCD 1 there, neutral RCD 2 there. Then we can bang these lines in, get the main cable through the bottom here, and everything should be powered up. So we'll do that next. Here we go, so we've got all the line cables in nicely, so they're all formed in. So we had to extend a few and just took a few connectors out and back, but that's all in now. So I've ended up moving a few of these, so we'll just neaten a few of these up, and that's looking great. So we've got all those neutrals in for his RCDs, so that's for RCD 1, that's for RCD 2. And it goes circuit 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's it. So we've got the bus bar to get in now. So bus bar, got the bus bar cover, and then if you look down here, I can angle this. There we go. So we've got that Henley connector block to put in. So I think the best bet, I don't know, I'll have to bang it under here then, something like that. So bang it there, get his cables in, the new cables into here, and then we can do some magic and get some power back onto this board then. Yeah, then I'll do that, and then we'll see it all power up nicely. Here we go, little beautiful install. So we've got all the cables going into the MCBs nicely. So it's time for the switch on. There's my phone alarm going off. So I'll do RCD. There we go, there he's setting fine. Oh, we've got some sort of fault. What have we got? What circuit's that? Garage and kitchen sockets, so we've got a fault here. I'll have to look into. Great. Right then, let's see what it is. So just a quick tip then for fault finding. So we're just going to provide a line to that circuit only. I've got a suspicion it's the garage. So just took the earth out, took the neutral out. No one's in there, no one's going to get a shock. And it's turned back on. So that tells me it's most likely an issue between neutral and earth on the garage circuit, so we'll have to see what's going on with that. But yeah, you turn the what's this, kitchen socket circuit on, and they're fine. So there's something in the garage we've got to investigate into. Great. So on that bombshell, I think we'll get some food. So might get a jacket tea if they've got any. Oh yeah. Here we go, nice and full now. So I headed up to get me a little tatty, and then I got a little call out. So I got ahead and to bring me a potato on the way. So I had to go to like a little socket thing that I'd set on fire, so I had to fix that. But yeah, back now. Yeah then, so let's get this labelled up. I'll just come up with this little contraption. So a bit of a 2.5 cable. What I'm gonna do is hook it here, hook it at the top of the board, and voila, it holds itself up, and then I can just label it up without this dropping on my hand all the time. Look at that legend piece of kit. Right, let's get this labelled up now. So before, there was circuit 1 to 10, and these are what they're doing, so let's get these labelled up. There's a few stickers to stick on. So we've got the 230 volt sticker, the next test date, mixed colours, RCD test sticker, wherever that's gone. So 230 volt, that's 400. Anyway, we'll get this stickered on, get it looking nice, neat and sweet, and then we'll nip into the testing. There we go, beautifully labelled up now. Spot on, and then we got the inside all done. It's got a bit of a reflection. Yeah, but I will have to buy new little printer, and the tapes are a bit fatter. So I've got a new Brother printer now because I lost my other one. But yeah, the tapes are 12mm. You can see that, so 12mm, and yeah, they're a bit fatter. So they don't stack very well. So you see that it says kitchen sockets. That's like overlay them a little bit, overlap them a bit. Yeah, the 9mm fits a bit better, but that's not too bad. That's looking neat and sweet. So now we're just going to go on to the testing. So if we whip the cover off, so that's all beautifully labelled. So we know we've got issues in the garage. So I went to the garage and came back and plugged the plug-in tester into one of the sockets, and basically it was flashing up one light which showed that live and neutral were wired the wrong way around. So it's called reverse polarity. So we're gonna have to investigate into that. So, but this grey cable, the twin earth, just pings through the wall, and it just lassos from the house to the garage. So it's got no UV protection. So what we're gonna have to do is pull that out, get some tubing in, and then push it back in. So at least it's got that protection there. So I think the garage needs rewiring ideally, but yeah, it's just all a big mess really. So it all needs all new lighting put in. It needs a few spare put in because there's lights and sockets. You know what I mean? It's on a 20 amp at the moment, so the smaller cable, if there's a high enough current going in through it, it's going to set on fire, and this won't necessarily trip. So right then, let's get on to testing. So yeah, we don't cover much testing 'cause it's a bit boring really, but yeah, we'll go through it quite snappy just so you can kind of see what we do. So first thing we're testing is we go around and do a visual check. So what we're checking for is like cracked switches, cracked sockets, that kind of thing. We normally, if it was in the ICR, well, we would test the circuit, so we hadn't done a fuse board changeover. We'd also look at the fuse board, make sure that the cables are protected, so that's also like a visual check. But yeah, so all we do is literally just go around and just check if there's any cracked switches, cracked sockets. Sometimes you get a bit of paint on them and you think it's a crack, but it's not, it rubs out. So stuff like that. So yeah, we're just going to go around, but I'll also show you the garage, because that's a bit knackered. So then, this is what we're dealing with. So light pings on, there's about 50 random lights. You know, you can kind of get to the back of those terminals, stuff like that, you know what I mean? So some stuff's just going to have to be ripped out. Like I said, the sockets, we plugged it in there, we've got reverse polarity, so that's no good. And the lighting is wired into the sockets as well. So if you have a look up here, the cable comes through over there. It kind of like strings between here and the house. But yeah, it just goes into this junction box, and then there's like little lighting cables there attached onto the higher socket cables, stuff like that. So ideally it all needs redoing. So obviously we'll just come through the cheapest option. Obviously wiring to your sockets. I mean, you can wire in and out if it's on a 20, bang it into a switch fuse spur which will down rate it, which will allow you to run your lighting cables then. And then it'll be just some lighting cables to your switch and then to your lights. You'll probably reuse these. Obviously we'll have to properly glam them in, so you can just get your whole finger in there, and it's just not very well done really. Same again here, I mean, big holes in stuff, and yeah, it's a right mess. Right then, so that's the visual side of it. So you basically just go around and just check everything's visually okay. Yeah, then we'll go into actual testing with the tester now. So record all the data on a app, or a piece of software called NOOooooo desktop. Now this is my old laptop, and I just bought a MacBook, and then I realised you can't even get NOOooooo desktop for the MacBook, so yeah, it's absolutely dead. I had to take it apart because you couldn't even get to the off button because the hinge snapped, so it's a bit dead at the moment, as you can see. So yeah, I need to come up with some sort of solution. Anyway, so then let's go on to this. So this is the software we use. So all we're going to do is type in like the reference, and then we can actually get into the test certificate. I'll show you what we're going to do from there. Right then, so let's go on to testing the first circuit. So then, let's have a look. So we'll fill this out in a bit, but the first circuit is the shower. So for Bob on here, so we took him out of the first position there, we took him out of the earth there, and we just banged them together. This little 6mm connector, so we just bang them together, it connects the line to earth. I'm just going to go in the shower and get a reading, so that's going to just give you like a resistance reading. There we go, so we're at the shower now, so we'll take the little fly lead out of here. Now if the shower's on, you took that out, it starts the shower up, so you've got to be careful of that. So just pop him down here and we'll just get a little continuity test. So what we'll do is go to his testers, bang him on, put it on continuity, a little light bulb if you want to see a bit better, and then so we can do this one-handed. So with a trick, so we get earth on there, that's your earth there, you've got line and neutral. Come on, there we go, look at that, one-handed testing. So it's got a little test button on this. If you hold it down, 1.06, that's quite high that. But I'll do a test again off camera, make sure I'm pushing them properly. But yeah, you basically get this test result and you just write it down. There's like a little section for R1, R2 on the report. So just gonna write that result in and then we'll move on to the next one. And then any observations I'll just write down on a piece of paper at the side. So everything has to pass with the EICR when you swap over the fuse box. So already I don't see an isolator in here, so there should be like a pull cord or a big red switch on the outside. So I'll have to check in the loft. If not, I'll have to put that down. You know what I mean? That it might need an isolator put in. There we go, that's better. So when I pulled this earth, it basically just fell off. So it wasn't very tight here at all. So we've just re-terminated it. We've got 0.13, so that's a lot lower. So that's what you'd expect from like a 6mm cable running about 10 metres. So that's all tight, so I'm happy that we've got a good reading, but we do need to check if there's an isolator somewhere for this. There we go, so just bang that result in there, 0.13. Then what we do is I pre-fill these, so greater than 500. That's like an insulation resistance test. So you send a 500 volt between live and earth, live and neutral, neutral and earth, with the loads disconnected, and it just tests the cable, make sure it's the insulation and broken down, and basically if it's below a certain number it'll just short to itself, so you need to know that it's more than 1 million ohms basically. Right, so to do that, most of the time they pass, you see, so you pre-fill that they've passed and you go back if they have failed. So you disconnect all your loads. I can take this out of here. So you disconnect your live, earth and neutral, so the neutral's got to bob out of there. Disconnect your loads up top, and then what you do is just clamp on earth, live, neutral, neutral, earth. Press test or your tester and it'll come out with the result. There we go then, nice and quick. So live, earth, over here, press test. So I'll only do 100 volts, then 250, then 500, just in case something's plugged in, but you see there it's 500 volts. And we've got a pass. And then you do the same again, neutral to earth. So just bang that on there like that. And then press test. And boom, it's passed. So because we pre-filled everything, we don't need to do anything. But if it did come up with a number in mega ohm, there we go, we'd have to change that. So there we go, that's insulation resistance test. So next little test we'll do is the socket test. So you've got something called a ring test, so the sockets are wired from the fuse box all the way around and back, so you've got a ring. So there's something called a ring test where you take the line cable out, the neutrals and earths, and you connect your tester from line going one way around to the line going the other way around, and it should be continuity. You should have a connection from one end to the other, and you should get a resistance. So you basically test that resistance, write it down on your certificate for line, earth and neutral, and we'll do that next. We'll explain the other ones in a bit. Do the line first then, so continuity, move to load. There we go, 0.28. So now I'm just going to bang it on neutral, so bear with me. There's no point stopping and starting really, it's quite a quick test. 0.28, top 0.27. So if you get more than 0.05, then each of they need to be investigating. So you've probably got a loose connection between line and, between the ends. So it could be like a loose connection in one of the sockets or like that. So you need to investigate and see where that is. And then we go, this is earth end to end, 0.68. So we're just going to record those readings in the table there. The next test we do is called the crossover test. So I know it's a bit higgledy there, but you basically take the line in and connect it to the earth out, and then you connect the earth into the line out, and then you go around with your socket tester. So I'll swap this to the socket tester attachment. I'm going to go around all the sockets, and we should be getting a reading, and they should be all roughly equal all the way around. If you get like a random spike or a random high one, it's either a bad connection in a socket or it's been like, so you got your ring, spurred and spurred and spurred, you know what I mean, that kind of thing. So let's have a look, let's do some testing. There we go, straight off the bat then. So 0.67 on this socket. Test the other side. 1.64. So obviously there's a bad connection on this one. This is why you test both sides. So this will need investigating into either the earth pins cleaning off and see if you get a better reading, or this will need swapping over. Here we go, got another issue. So we've been getting like 0.65 all the way around, give or take 0.05. But you go to test, you're getting greater than 2000, so there's no earth connection. But if you give it some wiggle while you do it, you can hear that beeping. You're getting like a 0.29. So for some reason at a certain position you're not getting earth on your socket, so this will need swapping out. So again, we'll detail it down. It'll need doing. So there's that one. We've also got a high reading over here. This was 1.64 when I plugged it in. See, so it's quite high that. Compared to those, it was 0.6 something. So what we do there, undo them two screws, pull it forward, you get a test to the cables coming in. And if you get in 0.65, then the socket will need swapping over. If it's a high reading, then it's probably just been spurred off a spur. So what we might need to do is just downgrade the breaker to like a 20, a B20 instead of a B32, which will mean that will land within the tolerance. So all the cables need to land within the tolerance when you're doing these tests. It's called a maximum ZS. So you basically add that reading to the incoming earth, and if it lands above a certain tolerance, then it don't pass. So then you've got to downgrade the breaker. Little fly there. So that's that circuit done. So obviously we've just got the insulation resistance, we've done that then, but you've seen that already. So I think that's about it for testing. So you've seen a radial test where we do the continuity, insulation resistance, write those test results in. And then you've seen the ring test for the sockets, so that's it for the actual circuits. But there's some other tests you do on the actual fuse board, so we'll do those next. So a little other test to be like lighting. So obviously any metal fittings, any metal switches, you're going to make sure they're earthed. And that's about it really. So all the tests are exactly the same. You basically do, you connect one end, go to test all the points, get the highest line and earth reading, you write down, do insulation resistance, and that's your testing. So we'll do the ZE test. So this is basically the earth reading from here all the way back to the transformer. So what we're gonna do, what you do is find the main earth coming in, you turn off all the power like so, and you test between, it's a live test, so you bang this on high current, and then you just test between line and the incoming earth. So you pull that out, disconnect all parallel paths, because this will be connected to the gas meter, which is a copper pipe going into the floor, so that'll provide other means of earthing, so you want to disconnect that. So we're going to pull the main earth out, clamp on it, and then test between those two. So there we go, it's on high current, it's ready to go. I've disconnected the earth. The main switch is off because you're basically disconnecting the earth to the full property, so you want to make sure that, well yeah, you don't want people touching these circuits and there could be a fault and getting electrocuted because you disconnect the main earth. You just basically bang it on there, press test, should pop out, so 0.32, so that's your ZE. And then we connect it back in, and then we write down this number, which is the PFC. So it could change depending on the parallel paths basically. So we're going to write that number in on the cert, and it's this number you add to your R1 R2 readings, which is your circuits Z, your circuits R1 R2 to get your ZS for that circuit, like we talked about earlier. So it's pretty complicated to understand, but you do get the hang of it eventually. There we go, main earth connect back in, press test. And this will pop out your PFC. So you see it's a slightly higher PFC because it's a lower ZE, and all that does is just do 240 volts divided by 0.3 to give you that basically. So we're going to write down 0.80. There we go. There we go, into the certificate. So external loop impedance ZE 0.32, and the PFC is 0.8. Nice one. So that's that test. There's the RCD test next. So these are little RCD units. What these do is measure the line going out through these circuits and coming back through your neutrals. And if there's any imbalance, i.e. a person touching it, it's going to trip within 0.4 of a second and save your life. So they're quite important. So one of the tests is that, which we do when we first power it up. Great. Oh, main switch is off. I thought it was broke. Right, there we go. So it does need power for it to actually test if that button works. There we go, so that's the functional test, the test button. And there's a little click button on the cert for that. So it actually says test button is it a test button operation, so you just ping it if it works and you click that, and then we've got 5 tests, we've got 5 results. Basically we test this and we write those test results down for these 5 circuits, and the test results for this one for these 5 circuits basically. Right then, we'll show you how you do with that. Just going to bang that on after dig time. We're now going to clamp the earth on there, and then we want the outgoing of the circuits. So just bang that on there, and then there's a little test button there, so I'll give that a little press. And what it's going to do now is test at half times the operating current, so 15 milliamps, 2 times the cycle. I'll test at 30 milliamps, which is what this is set to. I can't flick it up. There we go. It'll ping off again. Let's go test at 5 times 30, and ping off again. And then it's going to test at 5 times 30 again, but on 0. Basically test at 0 the cycle, 180 degree over the sine wave. There we go. It's actually RCD tested, so we've got 5 times there, so you just pick the highest one, so 13.1, and that needs to land under 40 milliseconds. And for 1 time it needs to land below 200 milliseconds, so 36 is fine. I'll test the other RCD now, so I just remembered I could clamp this on here, so got a bit better view now. So you just bang that on there, bang that on there, get a test. So that's 1 times, 180 degree cycle, 5 times at 0, 5 times at 180, there we go. And then here's his little test results again. So 14.6 and 26.9 is what we'll write down. There we go, that's all the fuse board tests done, all the incoming tests. There's little things you have to write down, like the incoming size. If you look there, it says 100 amp. It says it's a BS 1361 type 2. So it's these kind of results, these readings. I can't remember, it's not even a reading. These information you need to write down on your test sheet. That's about it. So we've got the ZE, we've got the RCD tests. Other thing we have to do is test that this cable does go to the pipe. So you get your wandering lead out and clamp it on one end, and then you go to the other end and clamp on and make sure that you're getting a reading, it's not chopped. So that's one of the tests as well. But yeah, we'll go through all the other tests now, testing them off. You've seen how we do it, so here we go. So just doing a bit more testing, and we've found, yeah, like a high reading to earth. So there's some reason we're getting like some funny voltages to earth. So just open this up. We've got a weird like metal back box with a plastic cover. So we're going to open this up and see what's going on. And I don't know. So there's been no grommet, random cable coming in. Yeah, not good, is it? And there we go, that's all put back together now. It's all wired correctly, so we get some funny readings there. So yeah, that's the fuse box done. That's it all swapped over. That's all the testing sorted out. So all the certs all filled out with. My laptop's gone over there. So we've got all those readings, so we're ready to produce that report. So we'll send this over, an EICR report, not an EICR, an EIR report, can't speak today. And then we've got to notify it. So what we do is just go on NOOooooo online, and we notify it to the local council basically. So we just say that for this property that this board's been installed basically, and they'll get like a certificate pinged over to their email address. So nice and easy. So then, if you like this kind of content, hit the like button, hit subscribe. As always, have a good one from me, and I'll see you on the next one.